Hi everyone. My name is Jerry Joe Thomas. I am a senior data scientist working at thinktum. I've been working in the AI space for like 8+ years now. So today at the Activate Virtual Search and AI conference, I am presenting the topic life insurance risk prediction. So let's start the presentation. So let's start with the introduction or the issue statement here. So in the life insurance industry, the applicants or the insurers are analyzed for risk through an underwriting process supported by specialists. So for an application to be considered, an insurer must submit multiple documents that may or may not include their medical records. So after this, the underwriting process begins and the risks are determined. So this involves various specialists and can be quite expensive, both in terms of resources as well as time. So artificial intelligence could help reduce the time it takes to do this calculations and fasten things up. So when I say artificial intelligence, I mean both the deep learning as well as machine learning algorithms. So yeah. So moving on to the solution part. Artificial intelligence, in artificial intelligence, there are three kinds of learning. One is like the supervised learning, then we have the unsupervised learning, and then we also have the semi-supervised learning, which is like a combination of supervised and unsupervised learning. So for the purpose of demonstration, I'm just going over the supervised and unsupervised learning here. So in supervised learning, we create labeled data sets. So how do we do that? So let's say in our industry, we go to the underwriters or the specialists and ask them, hey, can you please label the data set? That is, can you assign a risk score to each of the applicant? So this risk score can be numerical, or it can just be like a wording, like a text, high risk, medium risk, or low risk. This kind of the kind of labeling depends on the organization. So once we have this data set, so what do? We then use the different algorithms to train the model on this data set and predict the risk score or output. So we keep training this until we have the desired accuracy of the model, like the model predicts the risk pretty accurately. So in unsupervised learning, we only have unlabeled data sets. So the data sets here are designed to discover the hidden patterns without any human intervention. So how do we do this? So we have like lots of data from collected over months of the applications of the applicants, or maybe years worth of data. So once we have that, we run the unsupervised algorithms. So in this, the unsupervised algorithms can be as simple as the clusterings. So once the algorithms are run, we see different patterns or clusters within the data. Then we do some deep dive into this cluster or into this group, and we try to assign, like in our case, maybe a risk to each of this group. For example, let's say we find a group A. We deep dive into it and we see throughout the life insurance cycle how the applicants were behaving or how the applicants' outcome have been. So based on this, we would be able to assign a like, okay, the group A is a medium risk group, or we can assign a score 5.0. So this is how unsupervised learning works. We do not use any humans to do the labeling. The model does it for us. So for the purpose of demonstration, what I've used here is supervised learning algorithms. So let's move on to the data set here. So the data set I've used is a Prudential Life Insurance Assessment data set that is obtained from Kaggle, which is a competitive which is like a competition website for data scientists. So the data set here is a supervised data set that is labeled by experts for life insurance risk. The data set has like 50,000 plus observation, and each of the observation, which is an applicant or an application, has 128 features associated with it. These features range from the age, the body mass index, or the weight. Yeah. So, but let's just step back here. So here I'm using the data set that was created by this company, but every organization would have their own data, and they would be collecting different kind of information of the applicants. Maybe they have the textual data, or maybe they have the image data. So these algorithms can be used on any kind of data. It's not just limited to the 128 features which I'm using here. You can have your own data and you can use it and model it accordingly. So for the purpose of demonstration, I have limited here the data set to just numerical and categorical data. So let's just have a small overview on deep learning. So what is deep learning? Deep learning is basically an artificial neural network. So in our case, it is used to determine the risk of the applicant. So it is designed after the human brain. The system mimics the functions of the brain. So how different it is from a machine learning algorithm? So the machine learning algorithm generally are the tree-based algorithm, the distant trees, or the regression, linear regression, logistic regression. All these algorithms come under machine learning. So, but in case of deep learning, what we use here is a multi-layer perceptron. So what is perceptron? Perceptron is the simplest unit of a deep learning network. So deep learning is nothing but like you combine a lot of perceptrons using different activation functions, nonlinear connections, and create a statistical models from their learnings. So once the model is trained, when the model is training, you look at the output and you keep training or keep doing multiple iterations until your output is accurate enough or the error of the model is very less. So the deep learning itself is a very broad topic, so which cannot be summarized in like the 5-10 minute session. So I encourage you guys to go over how deep learning works and what are the interesting things about this algorithm. So let's jump into our model. So the model we have used here is a very simple model. It's like it has 5 layers of 5 layers. So yeah, this is just a simple picture of the model. So where you have the input features, and these are what we call the hidden layers, where all the magic of deep learning happens. And then we have the output layers, where the risk associated with each application is predicted. So here are the application data goes in, and here the risk score is outputted. So I trained the model for like 150 epochs. So I can share if anyone has any questions regarding the implementation or how many epochs or what are the learning rates or what are the different hyperparameters I've used in the model. Please feel free to reach out. So results. So the performance of the model is evaluated after the training to check if a risk model is helpful to evaluate the applications. So for comparison purposes, I have also trained an XGBoost model on the data. So the table summarizes the results. So if you could, you can clearly see that the deep learning model clearly is like it outperforms XGBoost here. The mean absolute error is like just 1.608, and in terms and the relative error is 0.2. So what does this mean? This results clearly shows that the deep learning model here has a very high precision in predicting the risk of an applicant, which is pretty good. So going to the analysis part of the model. So deep learning, it's not a black box anymore. Like a few years back, companies, like especially financial industry, the banks, or even life insurance industries, uh, deep learning is like a taboo subject because it's like a black box. You do not know what is happening behind the behind the algorithm, what is happening behind the algorithm. But that's not the case anymore. There are different techniques like LIME, which is called the local interpretable model agnostic explanations, which you can employ, which you can use with your model to see why certain things are happening. Like let's say you, for an application, you have a score of 8.0 or it's classified as high risk. Why does that happen? So using these techniques, you can see that, okay, maybe the weight or maybe the medical history or maybe the combination of weight and medical history in this case is giving this person a higher score, higher risk score. So in our case, I used the technique LIME, and I could see that the BMI, weight, and medical history are the main contributors to the model for the risk score. But these are not just the techniques. There are other techniques that are coming up every day. So there are new research papers on the model explanations that's being released almost like on a monthly basis, which are pretty advanced. So just wanted to put it out there that deep learning is not a black box anymore. You can know what's happening behind the algorithm, why you're getting certain results. So coming to the deployment part. So I know for a lot of people, it's very hard to trust artificial intelligence, especially like in the financial industry or like insurance industry. So what do you do in such a case? So you keep the model in the testing phase for like at least 6 months, and then you keep comparing the risk score assigned by the experts to the model's predictions. You always keep comparing. And let's say if the margin of error is very less, then you can go ahead and deploy the model. Like you can use a cloud solution, AWS, Google Cloud, or Azure, or use your own server. So, and then you keep coming back to the model every few months to see how it's performing. So you can always use a combination of the model's risk score with the expert score, which would like give you a peace of mind, and maybe it works in certain cases too. So, concluding with the future avenues of this project, you can see that the model performs extremely well only with just with the numerical and categorical data. So I've shown here the error, like the percentage error. So you can show the results in terms of accuracy, precision, or however you seem is perfect. So you can also add textual data as well as image data that's captured from the applicant's documents to improve the model. This would open up the avenues to use like strong natural language processing algorithms like BERT and many other models to improve the results. So that's it with the presentation. Thank you so much. If you guys have any questions regarding the implementation or the algorithm, please feel free to reach out to me. Thank you so much.